All right, let's start with the first one. Using the line of best fit, answer the following: true or false. All right. So the first one says, in 2014, the line of best fit predicted 49 pounds of food that will be given out. So 2014 would be right here. Go up and then go to the left, correct? Would that be 49? Yay? All right. So this would be true. You're right. Yeah, you're right. So it should say 49,000. It should say 49,000 instead of 49. That's how they get us. See, they got me right there. So you're right. It should be false. Thank you, Brian. Give your family 50 points. All right. Let's go to the next one. 2007 and 44 and 2008 and 45 are points that represent the line of best fit. So let's see. 2007 and 44, that will be this point right here. And 2008 and 45, probably that point over there. Are those line that represents, are those points that represent the line? No, they're not. They're not even in the line, right? So that would be what? False. All right. Next one. It's reasonable to estimate that in 2013 there will be 48,100 pounds of food to given out. So 2013? Yeah, that speaks the truth. Very good. So that would be true. To calculate the line of best fit, you decide to make X years since 2005. Data point 2011, 47. That will be this point right there. Becomes 647. Is that correct? I'm going to read it again. To calculate the line of best fit, you decide to make X years since 2005. Is that something that I can do? That I can say it's X years after 2005? That is correct. I can do that. Because that's your y-intercept. So that would be your x equals 0. And then the rest of your x's, we did this the last time we were here. Then the remainder of your x's would be how many years after that? So 2007 would be x equals what? 2. 2009 would be x equals 4. 2011 would be x equals 6, and so on. So the question is, can 2011 and 47 become 647? Yes, it can. So before we answer, can we please stop and think? It's the battle I have with some boys over here. And I'm losing it because I still haven't trained you on how to do it. We just want to answer, regardless of. All right, let's go to the next one. A scientist records the average number of cricket chirps in 14 seconds intervals at given temperatures. He determines the equation for the line of best fit below, where x is the number of cricket chirps and y is the temperature. Okay, so before I even go, I want to take a look at the scatter plot and figure out what kind of association or correlation does this have. It's definitely positive. Very good. Which means that what can you infer from the data? If it's a positive, what can you infer from the data? I can't hear you, baby. Go, go. Nobody can infer anything from the data? R is definitely close to 1. Yes, but I want to know what can you infer from the data. Or you can calculate. I want to know what can you infer. Very good. The more what? Very good. Give your family 50 points. Very good. The more cricket, it's chirps, not ships, right? The more cricket chirps we have, the higher the temperature it is, or the higher the temperature, the more cricket chirps we have, okay? So if the temperature is 84, predict the number of cricket chirps heard in 14 seconds. So if the temperature is 84, predict the number of cricket chirps heard in 14 seconds. So what would you use? The equation, because the graph does not give you 84. The graph only goes up to 80, right? You cannot extend the graph. You can extend the line, but you can't extend the graph. So the graph only goes all the way to 80, which means you have to use the equation. So now you need to understand what is y and what is x and what it's asking you to do. All right, so if the temperature is 84, what would that be? That would be y. Very good. So if y equals 84, what would be your x? That's what it's asking you to do. Because this is every 14 seconds, correct? So there are two things that you can do. You can either plug in the y and go to equation solver and solve the equation, or you can go to the table and figure out what is x when y equals 84. Okay, so I'm going to go to the y equal to. Now because this is a... oh, that's a lot. Is it an even 84? All right, so it's 89, 83.9, so we can say that it's how much? 41. Very good. All right, are we good? At what temperature will you heard about 30 cricket chirps in 14 seconds? So now this one, what is it asking you? When x equals 30, what is y? All right. So since we're already there, let's go up to x equals 30. And that would be what? 74. Very good. All right. So these are typical questions that they might ask you on the STAR test. This is probably one of the easiest questions. The scatter plots is one of the easiest things to do, especially on that test. Okay, so the table shows the trend in the number of people who read the newspaper daily in the U.S. The equation for the line of best fit is that one, where x is the years. So that's your x. And since 2004, and y is the number of daily newspapers readers in the millions. So now, what do you think we have less now? Newspaper readers. Do you actually have to buy the newspaper right now? Do you actually have to physically have the newspaper in huh? You can just go to the internet and the news are right there, right? Or you can subscribe and actually read it on your tablet or something like that. People don't pay for newspapers anymore because the internet is out there, right? All right, so how many people are reading the newspaper in 2020? What does that mean? What is it giving you? What is it asking you? Did you crush that bottle? You have to look for the what? You have to look for the y, most definitely. Nope. X doesn't equal 2020. What does x equal to? How much? I can't hear you, baby. I'm wearing this, so I can't hear you. How did you get that? Minus 20. 04. Very good. And that would be x equals 16, because remember, it's how many years after? All right, so you have two options. You can either write it on y equal to and go to the table and find what is y when x equals 16, or you can plug it in over there. You can say negative 6.3 times 16 plus 166. Either way, it's still going to get you the right answer. So talk to me. 65? Whoa, that's not too many, is there? Less than 100. 65 people will read the newspaper? 66 what? Oh, these are millions. I'm sorry. Yeah, I guess that is a lot. Mills. Okay. What year will there only be 52 million people in the U.S. reading the newspaper? Now, what is it asking you? It's asking you for the X. It's giving you the Y. The Y is 52 millions. And then it's asking you for the year. So be careful. So if you're going to do it with the table, you are looking for 52 million. You can say it's approximate, right? So we can say 18, but that's not the year. X equals 18, but it's asking you for the year. 18 what? Thank you. It would be 2004 plus 18. And you best believe that 2018 will be one of your choices. And we circle that one. So what year would it be? 2022. That is the year. Yay? All right, the amount of horsepower needed to carry tons of steel is recorded by the manager at steel plant. He tabulated his data to obtain the equation for the line of best fit, and that's the equation. Where X is the amount of horsepower required to move Y, weight in tons. So X is horsepower, and Y is the weight, is the tons, right? If the manager has a large machine with 180 horsepower, so what is it giving you? The X. It's giving you the X. It's telling you X equals 180. How many tons of steel could be moved? Are you going to go to the table for this one? Heck no. You're not scrolling all the way down to 180. That's too much work. In this case, you are going to plug in. That's the easiest way to do it, okay? So to plug in, you're going to say 0.0225, right? Are you with me? All right, so this is the equation. So we're going to plug in over here 180 for the X. You are not going to the table for this. You're not scrolling all the way down to 180. All right? Uh-huh. What does Y equal to? So 0.0225 times 180 plus 0.35. So that would be 4.4 tons of steel. All right. Are we good? Yay, let's go to the back and then let's do some family challenges. I'm not saying what I think right now because I'm recording. All right. All right, in Honolulu, there are many hairstylists. The table represents, I'm talking and you're talking over me. Oh my God, it's Monday. The table represents how much some of them charge and how many clients they have. So we got to determine, we got to make a scatter plot, we got to determine the equation of the line, and if Raven has 47, 45 clients using the equation for the line of best fit, predict how much she charges for a haircut. Okay, so let's start going ahead and what is my X and what is my Y? What depends on what? The cost of the haircut depends on the number of clients? All right, the other way around. So we got number of clients over here. And then we have the cost of the haircut. Yay? All right, so what's my, this is my X. And that's my Y. So what's my smallest X? 10, and my biggest one is 50. So we can definitely, I think we can definitely do this by fives. 10, 20, 30, 40, yeah. But then I'm going to have to do the flash sign, right? The wiggly lines for the Y. Because my smallest Y is 51, but it goes all the way to 92. So let's start at 50. And then we can do it by fives from there. Okay? All right, so 50 and 51. Let's go. 50 and 51. 10 and 89. 42 and 54. 15 and 92. 22 and 74. 18 and 79. 37 and 63. 26 and 65. 34 and 70. All right. So most definitely what? It's a most definitely a negative correlation. Let's make the line a best fit. All right. And then what can you infer? Talk to me about what you can infer. You can calculate that. What can you infer, Karen? Karen, she's the one that went for it first. Shh, Miguel, leave those girls alone. Okay, Miguel, go for it. Very good. Give your family 50 points. The the more clients I got, the less I have to charge. But if I have less clients, then I charge what? And I charge a lot more. Okay, does that make sense? Yeah, because it's volume, right? When I have a lot, I can charge a little bit less because I have a lot. I have a lot of volume. I have a lot of clients coming in, so I can charge a little less, right? Very good. All right, so let's come up with the equation of the line. Go. Where do you go for that? stats. It's definitely negative. Negative x plus 99. Double check, please. Mm. Yay? Oh my goodness. You two are going to end up marrying each other. You know that, right? More money, more problems. More bickering, more love. Stop it. All right. If Raven has 45 clients, what is that, X or Y? That is Y. Just, oh, 45, right? Just take a look at the table, right? Or at the table or at the graph. Using the equation for the line of best fit, predict how much. Now we got to use the equation. It doesn't say to go to table. It says use the equation. So what do I do? It says using the equation. What do I do? Plug it in. Very good. So I'm going to say 45 equals negative x plus 99. Because that's my y. So minus 99 divided by negative 1. Or you can go to equation solver, whatever you want. What would that be? 50 what? 54? 50, yeah? And then divided by negative 1. So what's the price? $54, right? All right. Last one. Samuel studies bald eagle populations in the United States and works towards making sure their population goes up every year. The table and graph represents the result of the census on the number of bald eagle pairs. Okay, draw a line of best fit. Should have been a little lower, but it's going to have to do because I already made it. So let's make a line of best fit and determine its equation. For the equation, what do we do? These are not your x's, correct? What are your x's? Tell me your x's. All right, but yeah, but I'm not going to put 1998 when I go to stat. Really? I'm going to put 1? Thank you. I'm going to put what? Your first year is always 0. First year is always 0. And then what would 2000 be? 1? 2, because it's how many years after that? Oh my God, we need tutoring. 2. What would 2002 be? 4, 6, 8, 10, and 12. There you go. Now I can do my stat, correct? You don't never put years on that stat. All right, so go to stat, do your thing. Tell me what the equation is. What do we got, my babies? All right, wait, start again. 310 x. All right. If this trend continues, how many bald eagle pairs will there be in 2012? What do you have? What is it asking? I can't hear. It's asking for the bald eagle pairs, which is y. If you don't know, just take a look at either your table or your graph. It's asking for y when x equals what? In 2012, If 2010 is 12, 2010 is 12, then 2012 is 14. Now, this one is not that bad. I would definitely go to the table if you don't want to plug in, okay? Or you can say 310 times 14. Either way is fine. Whatever you prefer. I am not going all the way down to 180, but I will do maybe 30. After that, I plug in. What do we got? 7,805. Are we good? Yay? All right, put that in your notebook. All right.